Hello everybody, this is Mr. Gerard here with another installment of our COVID special. We're looking at Algebra 2, Algebra with Trig 2, this guy right here. So there's a little QR code that links you, I think, to Khan Academy. And in this we're going to look at algebra that has trig embedded in it. And so we'll be looking at quadratics, square roots, absolute value, and fractional type equations. So we'll do a quick review of each of those, and then I'll give you some tips and pointers about how to manage these questions moving forward. Okay? So here we have a quadratic equation, x squared plus 5x equals 6, and a square root equation. You can read it over there. So let's look at the quadratic. If you recall, right, x squared and 5x are not like terms, so you can't gather them. So we have to, pull out our bag of tricks and see what we can recall. Now this goes back to grade 11. I remember doing it with my grade 10, so if you had me in grade 10, you might remember how to manage this too. And we have seen it a few times before. Okay, so here we had to move the 6 to the other side to make it equal to 0. Remember, we want to factor it, so we have two things that multiply to equal to 0. So you have to remember to do that step, because if you can figure out what makes each of those brackets equal to 0, and you multiply them together, 0 times anything is 0. So this is the standard process for solving quadratics. You'll see this in your work today, only we'll be embedding trig into this equation as well. Okay, let's have a look at the square roots over here and see how that one plays out. Now remember, the opposite of square root, how to cancel out a square root is to square. So we will be squaring both sides. Okay, so we square both sides, it gets rid of the square root, and now we have a quadratic equation. Big shock. So now let's go through and solve this like a proper quadratic equation. You have to make one side equal to 0, right? Factor, go through all that, see what you get. Okay, so we square both sides, right? We get our x squared. I want to make the x squared positive, so a few little bit of jig-jogging around, and I got this equation down here, okay, which factors to look like that, right? X minus 4 times x plus 3. And a lot of people just, they stay at that spot, and they're like, oh yeah, x is negative 4 and x is equal to positive 3, but you got to remember it's the opposites of those brackets is what makes them equal to 0. So, and there's our, those are our two solutions. Okay, so we'll have a look at absolute value, and then we'll have a look at fractional type questions, and we'll look at those. Okay, so absolute value and fractional, these are the two questions I'll look at. We'll do one more absolute value after I pause this video, but remember, absolute value tells us that whatever's inside those flat brackets, I know they look like ones, but they're really flat brackets, you make positive. So you take the absolute or absolute positive value of whatever number's in there. So if it's already 5, then it stays 5. If it's negative 5, then it turns into positive 5, right? Changes over. So if I extend this idea to say, well, okay, the absolute value of x plus 3 is equal to 5, I want to figure out what number makes x plus 3 equal to 5, and I want to figure out what makes x plus 3 equal to negative 5, because if I can figure that out, the absolute value part will turn into a positive 5, and I'll get another answer, right? So there's really two answers to this. In a way, it gets two answers similar to how a quadratic equation gets two answers. So, okay, let's go through the solution. Okay, so 2 will work, because 2 plus 3 is 5, and then you take the absolute value of 5, and you get 5. And then negative 8, because negative 8 plus 3 also gets you negative 5, and then when you take the absolute value part, right, take those flat brackets, you get yourself, positive 5 after you take its absolute value. So you're always splitting your absolute value into one for the positive and one for the negative. Now this is a very basic question. Let's get into something that's a little bit harder, and one that has an extraneous value in it. Okay, so here we go. Absolute value of x plus 6 is equal to 2x. And if we follow the same strategy as before, we just split it off into two separate questions and solve them. One for the positive 2x and one for the negative 2x. So, okay, so there we go. Split them up, and now let's solve them. Alright, so I split them up. I solve the one for the plus 2x, and I get x plus 6 equals 2x, and so I solve it, I get x equals 6, or 6 is equal to x. And the other side, I go through the same solution and I get x is equal to negative 2. But that's an extraneous value. If you look over here, there we go. If you plug in negative 2 there, you get a value of negative 4 on that side of the equation. And you can't have absolute values equaling a negative number. So if you plug that value in, you'll see you get an extraneous value. And so you'll have to watch for them. In fact, there was an extraneous value on the last example with square roots. I forgot to mention it to you. See if you can find it and let me know in the comments down there. Okay, so that's absolute value. Let's have a look at fractional equations. Over here, I've got an x on the bottom, and so I have to work to try to get that x off. There's a variety of ways to solve this. So I'll show you one way, and if you have a different way or a better way, then use it, and that's fine. But here's the way that I'm gonna illustrate for you guys. I got an x on the bottom, and that's the problem. So I have to work to try to get that x off the bottom, and I want to times the entire equation by the lowest common denominator. Yeah, whatever will take to cancel out the bottom part. In this case, I'm going to times the entire equation by x. Yep, you can times by x. You can do that. Okay, so the x times to both sides of the equations cancels out here, leaving me with a 6. And then over here, I got to fronter bomber that, or I guess backdoor bomber that in this case. So this will be what, x squared plus 1x. And guess what? Quadratic equation. So see if you can solve this quadratic equation. Okay, so x is equal to 2 and x is equal to negative 3. And you don't need to check for extraneous values here, or at least not in this case. The only time you have to worry about it is if you have to divide by 0, and that's pretty rare. It's really hard to create an equation that does that without looking kind of like I concocted it, right? It's really hard to make it look authentic. So you don't really see or have to worry about that. But you do have to worry about it for absolute values, and you have to worry about it for square roots. So now let's start embedding trigonometry into these equations, and let's have a look at a couple examples. Okay, so here we have tan squared theta plus 2 tan theta minus 8 equals 0. And to manage this, well, you have to think of it like a quadratic equation. And this tangent squared over here, right, tangent squared theta is the same as tangent theta all squared. They just write it like this to dispense with the brackets. If you didn't have the brackets, then the theta would be the only thing that would be squared, and that would make a complete mess of it. So that's what that means. And this solution style that I'm going to show you is the same solution style that we did in our probability unit, and it's the same that we did in our logarithmic unit, when we have two complex ideas embedded into a single equation. So we're basically going to call it a certain symbol, and then sub it out, and then sub it back in again. You've seen it a few times before, so here's another example of it. Okay, so when you sub it out, you get x squared plus 2x minus 8 equals 0. And that's a quadratic equation again, so we can factor that and find its answer, and so let's do that. Okay, so there's the answer for big X, but this is not our final thing, right? We've subbed out tangent theta for big X, so now we have to re-embed with the resub tangent theta back in for big X, right? These big X's are going to change to tangent thetas because that's what we said, right? Tangent theta is big X. And we're asked to solve for theta. So, not for x, because theta is the one that's in the original question. So I have to resub it back out. Alright, so once we sub tangent theta back in for x over here, excuse me, we have to solve for theta using inverse tangent. But remember, for the first one, right, I got a negative. So I keep it positive. I use positive 4, and I inverse tangent on that. And I just make the change to the cast rule when I get there. So when I do that, my calculator gives me 76 degrees, and for tangent theta equals 2, I get the same thing. I get, well, the same strategy. I get my reference angle is 63 degrees. So here, this is the cast rule for the first one. I got 76 degrees. Those are my reference angles, and now I have to calculate the principal angles. So I'm 76 degrees short of 180 over here, and I'm 76 degrees short of 360 over there. And then over here, this one here, my reference angle is 63. It's in positive tangent territory. So there, and there. So my first principal angle is 63. My second principal angle was 63 plus 180. So let's get those answers, and don't forget your coterminal statement. Okay, these are my numbers. I think they're good. I got my little coterminal statement down there, so I'm good there as well. And yep, so we wind up getting 4 answers. Because it's quadratic, we get 2 answers for x, and each of those answers for x gives us 2 answers for theta. So 2 times 2 is 4, we get 4 answers. And those are just little things to think about along the way. There's no extraneous values in this case, but there could be. Okay, so here's one that has absolute value in it. And our first job with absolute value is to isolate the absolute value bracket. So I got to cancel it out plus 4, and I got to divide off the 2. So let's do that, and then let's sub out the secant for some sort of variable you like. You guys remember which letter I like? Yeah, I like lambda. That's my favorite one. But maybe I'll use it. Okay, so I subbed out secant theta for lambda, and I had minus 4 to both sides, so I got this 2 times the absolute value brackets. Got to divide off the 2. Isolate the absolute value brackets as a first step. Okay, so I divided off the 2, and I get absolute value of lambda minus 1 equals 3. And now I split the equation into 2 parts, one for the positive 3 and one for the negative 3. Okay, so I got my lambda equals 4, my lambda equals negative 2. Okay, now I've got my answer for lambda. I have to sub back in for secant. So we're going to have to just remember how to manage those particular questions. Hopefully this shouldn't be too much of a big strain for you, because it was on the last video, the one previous to this. Okay, so subbed in secant, and remember secant is 1 over cosine. So you change your secants to cosines, or 1 over cosines, and now you have to flip both fractions. Okay, so I flip both. I flip both fractions. 1 over cos becomes cos over 1, or just cos. And then 1/4, well, that's 0.25. You plug that in on your calculator, you get a reference angle of 76. Over here on the other side, remember to keep your number positive for your calculator. So even though it says cos negative 1/2, you do inverse cos positive 1/2, and then you worry about the negative in the cast rule. So I'm not going to draw the cast rule because I really don't have space, but I want to see if you guys can figure out the 2 principal angles. Okay, so I got the first principal angles down there, and the second principal angles down there, and I also got my coterminal angles. So what is it? 76 and 284 for the first part, and then 120 and 240 for the second part. 4 separate answers, and my coterminal statement. So, show that, please. Okay, so that's absolute value. Let's have a look at square roots. Alright, so here's a square root with some trig inside it. The square root of cosecant theta plus 2 is equal to cosecant theta. Okay, so sub out cosecant for x, and see if you can solve for x or for whatever symbol you like. Okay, so I subbed out the cosecant for x, and now I have to square both sides in order to get rid of the square root. Okay, so there's the quadratic, right? X squared on one side and x plus 12 on the other. Got to make it equal to 0. So in my mind, I'm going to be moving the x and the 12 to the side with the positive x squared. So I'll rewrite that out, see if you can solve it, at least for x, and then we'll sort out the trig part. Okay, so I went through the solution, and I got x is equal to 4 and x is equal to negative 3, but it just so happens that negative 3 is extraneous, because when we plug it into the equation, this guy right up here, where the arrow is, negative 3 cannot be the result of a square root. Right? Square roots only give you positive numbers. Like, so square root of 9 is positive 3. So there's no other number that could even get you close. So that's why we have ourselves an extraneous value. That was one of the things I mentioned earlier from my previous example. There's extraneous values with this. So I don't need to do anything else. It's a bad answer. As you recall, right, algebra is really a set of little tricks. And sometimes those tricks, they break down because the operating system of algebra comes in at different times than our knowledge of square roots and absolute values, and so those two operating systems clash, and we have these little bugs that happen. And so this is one of those situations. We get a bug. We have to remember that it's there and remember to fix it. So, alright, so we only have one answer. That's nice. makes our calculation for cosecant half as large. So now that we know what x is, let's sub in cosecant and see if we can solve. Okie dokie, so sign's positive, so we have the zones for A and S, and those are I found my reference angle of 15 degrees. So my first principal angle will be the same as my reference because it's in the first quadrant. And the second one, well, I'm short of 180, so I got to minus the 15 from 180. Okay, so I got 15 degrees and 165 degrees, and I've got my coterminal statement. Pow! Okay, so don't forget those. I know I harp on it, but don't forget them. So I'm going to end this video here. There's still a few more that I want to look at, like using logarithms and exponents, and sorting some of those types of questions out, which I'll put in the next video for us for now. But for now, that's enough to get you up to, I think, page 3, if I'm not mistaken. Let me have a look. You can do page 1 and part of page 2, it looks like. So you can do up to, let's see, page 1, page 2, page 3. You can do up to page 3. Alright, so yeah, as soon as you start getting into exponents and that kind of stuff, then you might need a little bit of extra advice, which I'll provide for you in the next video. Take care, guys.